My name is Olajide Michael Busayo. The topic of my project presentation is Power Generation Problem in Nigeria, the Way Out. The degree of economic growth and industrialization of any nation is dependent on the ability of such a nation to produce a sufficient amounts and quality of electric power and effectively distribute it to homes and industries. For Nigeria to become one of the most 20 developed economies in the world, the issue of power crisis, which has lingered for decades, must be totally resolved. It is of note that Nigeria is blessed with a wide varieties of renewable and non-renewable energy that can resolve the power crisis Nigeria is facing. But despite the abundant energy resources available in Nigeria, the country still remains one of the least electric power consumer per capita in Africa. When compared to that of South Africa, Egypt, Libya, and Namibia, the electric power consumption of Nigeria is very low. The peak electric generation achieved in Nigeria in 2021 is 5,615.40 megawatts, which is about 28.3% of the national electric demand forecasts of 19,100 megawatts for the year. Currently, the energy mix in Nigeria is dominated by thermal, which is 80%, and hydro 20%. In a bid to resolve this power crisis in Nigeria, the government partially deregulated the power sector, which has resulted in the need to explore several options for electricity generation to increase power capacity and its ability and its reliability in the country. And one of the possibilities is to reduce the over-dependency on centralized generation by introducing a decentralized hybrid system in Nigeria. Also, to diversify the power generation in Nigeria from conventional energy sources to other alternative means. And for Nigeria to meet its annual demand projection of 297,000 megawatts at the end of 2030, an approximately 11,700 megawatts need to be generated annually. This means that all potential energy resources in the country must be sufficiently harnessed to meet the country's electric need. The aim of this work is to design a modern decentralized hybrid system as a solution to the problem of power generation in Nigeria, using Ondo State as a case study. Ondo State is used in this research work because of its rich natural resources and climate that could be harnessed to generate electricity. Ondo State is located in the southwestern part of Nigeria with a population of 3,441,024 and a land area of 14,606 kilometers. Design of a model hybrid generating system using OMA software. A model hybrid power plant is designed using OMA simulation as a model to resolve the issue of power crisis in Nigeria. The system consists of a wind turbine, DC generator, and solar PVC with a battery, as you could see in the schematic diagram below. DC generator. For the proposed model, a DC generator rated 2.7 kilowatts was used, and from OMA, the capital and maintenance cost of the generation is $1,350 and $87.2 per year. The operational life of the generator is about 13.9 years, and the graph below shows the graph of fuel consumption against power output. Wind resources. This modeling uses 2.64 kilowatt DC rated power for the wind turbine. The two graphs below shows the graph of the power curve and the wind speed curve of the turbine. Solar photovoltaic array PV. The PV used in this study is generic flat plate PV. The average solar radiation of the study area is 4.76 kilowatt hour meter square per day, and a clearness index of 0.48 was identified. And this is shown in the graph below. It shows the daily radiation of Ondo State. The total net present cost of the array is $30,304.41, while the operating cost is $1,427.35 per year. The result of each of the variables is shown here. The generic flat plate PV, the nominal capacity is 2.46, as I've said earlier on. The annual production is 3,631 kilowatt per year, and the rated capacity is 2.46. The capital cost is $6,606. Specific field 1,374 kilowatt hour per kilowatt. The PV penetration is 88.3%. The total production is 3,631 kilowatt. The maintenance cost is also shown. Likewise for the generator also. All the variables were shown. The operational life of the generator is 13.9 per year. The capacity is 2.7. The capital cost is 1,350. The fuel consumption, the operation of the hours, the fixed generation fuel is diesel, and the generator fuel price is $1.0 per liter. The maintenance cost is 87.2 per year. Electric generation. Then we also have the specific, the storage is generic 1 kilowatt lead acid, and the converter system was used. Conclusion: OMA Energy software results in this simulation shows that combining different means of energy sources is more economical and practical than single source of energy system that is being used in Nigeria. Presently, Nigeria makes use of hydro and thermal to generate the electricity alone. But if different combinations were used together with this hydro, it will help the power generation system in Nigeria. And that's the essence of this work. That's different combination of diesel generator, solar PVC, and wind with battery for storage model in this work shows that the problem of Nigeria energy generation can be alleviated using different mix of energy sources. This work has also shown that decentralizing Nigeria energy generation is still the most visible means of solving Nigerian power generation. This will put an end to the issue of the downtime that is being experienced in the national grid if each of the state or communities are allowed to generate their electricity themselves. Thank you.